Hi, my name's Steve Johnson. This is one in a series of video tutorials that we do to supplement what we do in our monthly newsletter. This particular time, what I'd like to talk about is the possibilities of long exposures with some of the new digital cameras that we have nowadays. Now, of course, one of the problems with long exposures traditionally has been that we didn't know exactly how long of an exposure to give the film. Film had this peculiar characteristic of failing to respond to very long exposures in the same way it did to very short exposures. It was called reciprocity failure. And we ended up with these fairly elaborate methods of testing and calculating what the actual exposure the film would need to have in order to behave in a way that was predictable. Well, of course, nowadays we don't have the same kind of reciprocity failure in silicon that we had in silver, but we've got a whole new level of problems with the long exposures, with the fact that the longer a silicon chip is absorbing light, the more noise builds within that exposure. So very cleverly, a tactic from astrophotography has been introduced whereby a photograph is made at whatever length of time you think appropriate, from say 30 seconds to a minute to 5 minutes or 10 minutes. And then the shutter is closed by the camera's system. An equally long exposure is made called a dark current or noise frame, and that noise structure that's built up on the sensor during that long exposure is then subtracted from the exposure that was just made by the camera of the real world light, and we end up with a noise reduction map that acts on your original long exposure photograph, and it cleans up a great deal of the sensor noise. This is a standard practice in astrophotography. We now have digital camera systems that allow you through long exposure noise reduction modes to be able to do this in an almost automatic fashion. And it really is a substantial improvement to what we could do with digital SLRs and long exposures. It's a wonderful kind of addition to the process. Now, there are additional challenges that come up with long exposures. One of them is simply being able to focus in low light. So one of the things I've carried in my camera bag for years is a green laser so that I can point that laser at the subject plane and have a pinpoint of green light to be able to focus my camera on. That can help a great deal to be able to focus on things that are just too dim to be able to focus on, and where the autofocus mechanisms themselves are really not working. Is the ability of the sensor itself to be able to gather light. It's ironic, but the lower resolution cameras that are full frame or nearly full frame in 35 millimeter actually have bigger pixel wells to gather the light than the higher resolution cameras, which have of necessity much smaller individual pixel wells because they're cramming more of them into the same space. Those lower resolution cameras actually have a greater ability to gather light than the higher resolution sensors, simply because there is more silicon present with every pixel well, so there is inherently more photon recording capability. So we've had some interesting experiences out on some of the field workshops where we've gone out to photograph at night, and someone next to me with a 6 megapixel camera from the early 2000s with my higher resolution Canon and Nikon, whatever camera it might be, in the more 18 to 20 megapixel range, actually had less sensitivity to the real low light than someone with the older 6 to 8 to 12 megapixel camera that simply had inherently bigger pixel wells. And some of the differences we could see is that there were times when the Milky Way would actually pick up in the photograph on the lower resolution cameras, whereas star trails themselves were barely picking up on the higher resolution camera, even with the same optics, the same ISO, and the same length of exposure time. So there's lots of considerations, some of which are obvious, some of which are more subtle. But long exposure photography, especially with these new long exposure noise reduction modes can just be a great deal of fun. And I would really encourage people to experiment with it, because not only do you mess with time, the passage of time, the rotation of the Earth if stars are involved, but it gives you a whole different look at the world that the nighttime can bring, that is just a very different world than the daytime. Hope that helps.